All right, today we're going to pull back the curtain on one of the most, well, fundamental and powerful services in the cloud. Azure Queue Storage. It's kind of like the invisible engine that keeps so many of your favorite apps from crashing, and we're about to find out exactly how it does that.
So let's kick things off with a scene I bet we've all been through, right? You're scrambling to get tickets for that huge concert, or maybe it's Black Friday and you're trying to snag that amazing deal online, and then, boom, the website just stops. It freezes up. So what's going on here? Why do these super powerful systems sometimes just buckle under pressure?
Well, the answer, when you really boil it down, is actually super simple. It's being asked to do way too much, way too fast. Think of it like a digital stampede, and the server just cannot keep up.
What this does is create a massive digital traffic jam. I mean, just picture every single car trying to squeeze through one tiny intersection at the exact same time. It's not going to work, right? You see, this whole do-it-all-now approach, it actually has a name. It's called synchronous processing. The system is literally trying to handle every single request the second it comes in, from beginning to end, before it even thinks about looking at the next one. And this creates a huge bottleneck. It's like having a single toll booth on a 10-lane highway. The system gets totally overwhelmed, it slows down to a crawl, and yeah, eventually it can just fail completely. Okay, so if trying to do everything at once is the big problem, then what's the solution? Well, it's all about changing the timing. It's about working asynchronously. And that right there is where Azure Queue Storage comes into the picture. So what is it really? Well, Azure Queue Storage is basically a service for storing tons and tons of messages. But here's the key. These messages don't get processed instantly. Nope. Instead, they form a backlog, a to-do list of jobs that can be worked on whenever the system actually has the capacity to handle them. And here's the real magic. What it does is it decouples the front end from the back end. The part of your app that's taking in all the requests is now totally separate from the part that's actually doing the heavy lifting. And what does that mean for you? It means the front end can stay super fast and responsive, no matter how slammed the back end gets. You can scale each part on its own, which makes the entire system way more resilient and, honestly, massively more scalable.
To really wrap our heads around this, let's step away from the code for a second and think about something we all understand, a busy restaurant. This analogy is just perfect for explaining how a queue works.
Okay, picture this. You're a waiter. A customer gives you their order. That's the request. Now, you don't just drop everything and run to the kitchen to cook it yourself, right? Of course not. Other customers would be waiting forever. No, you write the order on a ticket and you stick it in the queue for the chefs. That little ticket, that's our message in the queue. The chefs, they're our background workers. They just grab the tickets one by one and get to cooking. And here's the most important part. While the chefs are busy, you, the front end, are totally free to take more orders, keeping the whole restaurant running smoothly. All right, I think we've got the restaurant analogy down. So let's swap that chef's hat for a developer's cap and look at the actual technical pieces that make Azure Queue Storage work. It's all built on three really simple blocks. First up, you've got the storage account. Just think of this as the entire restaurant building. It's the big, top-level container for everything. Then, inside that building, you have one or more queues. These are like those ticket rails in the kitchen where the orders line up. And finally, of course, you have the message itself. That's the individual order ticket. Now, as you start creating these queues, here is a little, but trust me, critical detail that trips up so many developers. The queue name, it has to be all lowercase. I know, it sounds so minor, but it's one of those simple rules that will save you hours of painful debugging if you just remember it from the get-go. So how much info can you actually cram onto one of these order tickets? Well, the maximum size for a single message is 64 kilobytes. And look, that's not huge, and that's totally by design. It forces you to keep your messages small, lightweight, and super fast. It's perfect for things like sending instructions or unique IDs, or maybe even a link to some bigger chunk of data that you've stored somewhere else, like an Azure Blob Storage. And another cool thing, these messages don't have to live forever. By default, a message will just expire and vanish from the queue after 7 days. But let's say you've got a really long-running process. Well, you can also set that message to never expire, so you get total control over how long your jobs stick around. And when you put it all together, every single queue gets its own simple URL. You can see the structure here. It's just your unique storage account name, then the standard Azure bit, and then finally, your specific all lowercase queue name. It's a super straightforward and predictable way to talk to your backlog of work.
Okay, let's bring this all home. At the end of the day, we're not just, storing random data here. We are building better, smarter backlogs of work for our applications. Just look at this comparison for a second. The old way, the synchronous way, the front end is just stuck there, waiting. If one little thing fails, the whole system can grind to a halt, and it just can't handle sudden spikes in traffic. But with the queue, the asynchronous way, the front end is totally free to move on. The back end processes stuff whenever it's ready, and it could absorb these huge traffic spikes without even breaking a sweat. For reliability, this is an absolute game changer.
And that really brings us to this key idea from the source material, which just perfectly sums it all up. The main job of a queue is to create that backlog of work, so your system can process it asynchronously on its own schedule, not when it's being bombarded.
So I'll leave you with this question to chew on. Think about your day: sending an email, uploading a photo, ordering food for delivery. What part of your digital life is secretly running on a hidden, hard-working queue, just like the one we talked about? I bet the answer is a whole lot more than you think. Thanks for diving into this with me.